Okay, hello everyone to LeetCode Day 3, and today we're going to be solving group anagrams, and we're going to basically take everything we've learned from LeetCode Days 1 and Days 2 and the most optimal solution and sort of make an optimal solution for group anagrams. If you haven't seen the video I made yesterday, it's about anagrams, so this is going to kind of help you sort of create an algorithm for group anagrams. Um, So here we are given an array of string strs. Group all anagrams together into sublists. You may return the output in any order. An anagram is a string that contains the same exact characters as another string, but the order of the characters can be different. So we have act, pots, tops, cat, stop, hat, and in hat, we have it as its own sublist. We have act and cat as their own sublist because these guys are anagrams. And we have stop, pots, and tops in their own sublist because they're already um, in their, um, they're all anagrams. I haven't actually, I have solved these questions before a long while back. I think in my first video I talked about how I solved it in around March. So I'm kind of going through this head on and at from scratch. Sorry, I had a little aneurysm there, but in order to solve it, and it's gonna be uncut. So if you want to skip, you can skip. Just learning, trying to document my journey in terms of speaking properly in interviews and for interviews, and also explaining my thinking as I go. And I have a notepad here just in case we need to sort of visualize things, and I think it's the best way to learn. Um, so the way I solved it before was kind of creating a hash map to store um, um, uh, the the values as tuples. So I think the hash map I'm creating here is hash map equal to default dict, and this is going to be a tuple hash map. I may need to GPT some of this syntax because I'm not sure if um, they all work, but I guess that's the point of learning. So this is going to be my result array. So basically we can see that it's a list of lists. So we need a list to start off with. So I'm going to do a for loop. So we want to solve this in ON time complexity. OM times N time complexity where M is the space. Or N and M is the space. Where M is the number of strings and N is the length of the longest string. So you want to first go through each uh, index of uh, the list. So what I'm going to do is for I in range len strs, which goes to the length of the list, we then need to sort of go through every single character within this string. So to do that, we can do so I'll do the the word equals strs at I, and we can do now we have to convert this into a tuple because we want to see if this word as a tuple is already in the hash map, and we want to sort it as well. So we want to take this and we want to put it, we want to cast it as a tuple. I believe we sort after we cast it. I'm not too sure if that's the syntax, but we will kind of search that out. I'm sorry, I'm kind of working through this, so let's see how this is. So we can actually search this up. How to cast word to tuple, or cast string to tuple and sort the tuple. Then you just look at, yes, so you would have to cast it to a tuple and then you have to sort it by using sorted. It's not sort, it's sorted. So yeah, and basically what that does is it takes act, and then well, this is already in order, so it'll take pots and, okay, let's just do CAB because it's just faster and easier. Let's just say it's CAB, it turns it into tuple, so it goes tuple is C, A, B, and then it takes that and then it goes, after it sorts, it just goes A, B, C. And this is just for identifying if the word is in the hash map or not. If word in hash map, then we want to say res at. So we now, okay, if the word is in the hash map, we know that there's already a subset where there exists an anagram that is the same as this word, right? So we want to actually append it at that specific index, and to get that index, we need to actually store it when we don't have the word. So the else case would be just storing the index that we're currently on. But before that, we can just actually do that now. So we can say that res at hashmap, the word, or yeah, the word dot append stirs at I. So what this does is it looks through an array. So it'll look through, let's just say ta, or let's say we only have act in this array, and we are just now adding cat. It'll go through the hash map and see, is there something that is already in the hash map that has the word, has the same letters as act, as cat, sorry. And then we'd go through the hash map and we'd see that, okay, act is actually in the hash map, and it has the same letters as cat, and it's at index 1, so 0 and 1, because we're going to store that later. So then when we do hash map at word, our value is going to be 1 here, and then it says res at 1, so meaning the whole output, the output array, the result at index 1, append this specific word to the subarray. Okay, and so that's what we're going to do now. So we're going to do else. If word is not in the hash map, we want to append it. So we want to say hash map at word equals. So we want to actually keep a counter here to see how long it is. So we're going to say equals idx. So now we say it's at index 0 now because it's their first word, and we're going to increment it, and because the next iteration it'll use 1, and here we increment it, and we also have to do one more thing. We have to append it to res. So res at idx dot append a subarray stirs at I. Okay. So we're saying at this index, append strs at I, which is going to be in a subarray right here. Okay, and then we'll go through the whole array or the whole strs array and continue this algorithm, and we'll end up having something like this. So we can return res here after we're done. So let's just run this and make sure we didn't mess up anything. I forget how this works. I think this works. I'm sorry, I'm like... Okay, so this is where I messed up before list. I think this is going to have to be list. I don't know if this works. I genuinely don't know. Okay, so this is what I do now. I don't know. I'm not sure. I think it needs to be tuple. Apparently you can't use list as a dict, but I think there's a way to do it. I just don't know if it's tuple or not. So this is when I would go here and just check, and we can learn from this together. See, I'm still learning. Not really sure why this is the case. Okay, let's see why. Oh. Oh, I need to sort. I need to sort it first. And then tuple, apparently? No, I don't know if that's true. This needs to go here because we want to not append it to something, the wrong index. Oh, we don't even have to do this. We can just dot append. Right, because we're appending to the last point of the array. Yeah, so I guess that's how it worked. I think the issue here was the fact that we sorted after we did the tuple. So that kind of reverted the action that we were looking for. So we wanted to actually start from sorting and then cast it into a tuple so that we would have it in this sort of manner, which was that coincided with how we defined the hash map. I think that's what it's saying right here. It said your word variable is actually a list, not a tuple. Tuples are immutable and can be hashed. Lists are immutable and cannot be hashed. If your sorted tuple is accidentally a sorted list, which is what the sorted function returns by default, Python will throw a type error on hashable type list. So right, so our sorted function returns a list, so we need to cast that back into a tuple, which then we can sort of then check if it's within our hash map or not and populate our hash map. And this way we get a solution that I hope passes, and here we see that we have passed every case. Right. Okay, so I don't know if this made a lot of sense, but I'm going to actually run through a demo of what this code actually does. Because I know it's hard sometimes to understand code when it just out there in the open, and like some people have the ability to code, but they just don't know how things work. And I think like like how the problem works, and I think like my goal is to sort of show how that occurs and how we can get to the actual solution. I'm going to do axe pots tops cat in this example. So we are given, let's say, I'm going to do this, axe pots, what was it, tops and cat. And let's see, we want to return, say that we wanted to return the anagrams, okay? This is res, let's just say for now, this is res. Okay. So our algorithm basically does this. We say, let's go through the first, so it says for I in range len stirs. So we are going through the length of the array. We're iterating that many times, and we're taking the word. So what our word does is we sort the stirs at I. So we sort axe, and we get A, S, T. Oh, sorry, there's no S in there. Sorry, we just act, because then it wouldn't be an anagram. But yeah, let's just say we remove this. Sorry. So it'd actually be A, C, T, just how it is. This is not there. Oh. Okay, I hope this is legible. And that is our first um, tuple. So we then sort it, and this becomes a tuple, so it becomes A, C, T. And then we check, okay, is this already in the hash map? No, it is not, because it is the first iteration, right? So we then say, we go check our condition, we say, okay, hashmap by word equals IDX. So we're now saying hash this value into the hash map, which is a dictionary, and then give it the index 0. Because when we do, if we are going to come back to this, we need to know if we are to find something else down the line that has this tuple value, we need to know what index it is so we can append it. And then we want to append it to our result array, the word. So we just do res dot append the stirs at I, which at this point is just act and is empty, right? So we put a bracket here to indicate that it's in a subarray. So it'll be like this. So then now res turns into obviously it's a string, but okay, I'm just gonna add as two things. So in the sake of time, let's just say that tops and cats are not there, and like the array is actually just act and cat, because I'm going way too long, longer than I intended. Well, let's just say it's act and cat here, and sorry, this is not act, it's just cat. I mean act. Okay. So the next iteration, okay, let's go to the next iteration. Our next iteration is going to be index 1. So we go through the whole step again. So we see here, we are on index 1, and we're going to sort the stirs at I, and we're going to also make it into a tuple. So sorting cat, let me just say sorting cat here. So sorting cat leaves us to ACT, and then we tuple that, so we get A, C, and T. And this, then we check, does hash make it different from the other example, is this tuple ACT in hash? Well, this would return true, right? Because we seen that we already put the hash at ACT equals 0. So once it returns true, we do this: res at hash at ACT dot append stirs at I. So now iteration is 1, so I equals 1. So we are looking at cat here. Now hash at ACT we know is equal to 0 because we just hashed it right here. So we're saying res at 0 at this index, so at this index right here, append to the subarray cat, because that's our index right now, because we're stirs at I, index 1. If we look at our array, it's cat now, right? So then our res array turns out to be a whole array and a subarray ACT and CAT, right? And that's the whole solution. And that's basically our whole algorithm. That's basically every step of the way. That's what we did in our algorithm. And knowing this now, you can probably go back and without looking solve this because you know the whole step and process. And I hope that made sense to you all. And that's how I understood it. I kind of just drove things out and I kind of figure out how to translate it into code because I think a lot of times individuals know how to code, just the fact that they can't translate the idea into the code, or not. They don't have the idea to translate it into code. And yeah, I hope you enjoyed, and I hope that was explanatory. I'm trying to do better every day. I hope you guys can see a difference. I don't know. It's only been 3 days, so I'm probably like pretty helpful for no reason. But I hope you understood and hope you enjoyed. And um, leave a comment letting me know how I did and how I can improve because I'm just trying to get better. Thank you. Thanks for watching.